Hello everybody, this is Mr. Regener, and this is going to be a sort of quick review of the assessment practice for topic 2. So I'm looking at pages 73 and 74 inside of your math book. So I'll look at the problems and try to solve them here on the video, which might help you. So you can kind of follow along with the work that you did and check yourself, or you can kind of complete the work along with me. Feel free to pause or rewind the video as needed to help yourself out. So starting off with number 1, it says Kayla's dollhouse has 15 and 1500 square feet downstairs and 6 and 4500 square feet upstairs. What is the estimated total area if you round the decimals to the nearest tenth? So I'm going to go ahead and pull up my work here and looking at number 1. Number 1 says, there we go. I gotta find my papers. That I've got my numbers and I'm going to round to the nearest tenths place. So whenever I'm rounding, I like to underline the place value that I'm rounding to. The next step is to look at the numbers to the right and figure out if those numbers are going to go up or if they're going to stay the same. So if I'm rounding here, I'm going to have sort of equal numbers here. I put that little kind of equal sign. 15 and 1 the 1 in 15 is actually going to go up. The 5 tells that 1 to go up. So this becomes 15 and 2/10. The same is true with the 5 here next to the 4. That 4 goes up, so it becomes 6 and 5/10. Now it's just a matter of adding them together because I'm trying to find the total area. So 2 plus 5 is 7. Drop my decimal down. 6 plus 5 is 11. 1 plus 1 is 2. I get 21 and 7/10. And take a look at it. Boop, there's my answer, 21 and 7/10. For number 2, it says estimate the sum of $12.15, $16.85, and $1.74 by rounding each number to the nearest tenth. So once again, I'm going to take my numbers from the problem and I'm going to round to the nearest tenths place. So I'm going to underline the tenths place. I'm going to think about the number to the right and how that affects the number in the tenths place. So if I look at the first one, the 5 tells the 1 to go up. That becomes $12 and now 20 cents. Notice I put that 0 on there because we're talking about money. So I always want to keep that 0 because when we talk about money, we always go to the hundreds place. Okay, I've got another one. The 5 tells the 8 to go up. Round up. So now I have $16.90. And the 4 tells the 7 to stay there. That's going to be $1.70. Notice that my decimals are lined up. Now I just need to add them all together. So I have 0 plus 0 plus 0, which is 0. Notice, by the way, I'm trying to add all 3 numbers at one time. If that's too overwhelming, just add 2 of them at a time. Or maybe use some mental math to combine and use the associative property, the commutative property to do that. So next I have 9 plus 2, well, that's 11. And then 11 plus 7, well, that's 18. So I'm going to put my 8, carry that 1 over, drop the decimal down. Okay, now we're getting complicated. We've got 4 numbers to add together. 1 plus 2 is 3. 3 plus 6 is 9. 9 plus 1 is 10. Carry that one up. 1 plus 1 plus 1 is 3. So my final answer here is $30.80. Let's take a look at our answer. Bloop, there it is, letter B, $30.80. Let's move on now and take a look at number 3. Again, I know I'm kind of going quickly. What is the sum of 2 and 6500ths plus 3 and 7800ths? Keep in mind, it doesn't say that we're estimating anymore. So no longer do we need to worry about rounding or estimating. We are just calculating this out. A lot of ways to do it. Remember, we could use mental math. We could compensate if we need to. I'm just going to do this the traditional method. So I've set up my numbers. I've lined up my decimal places. And now I'm just going to add. So I have 8 plus 5. That's going to give me 13. My one up top. I have 7 plus 6 plus that 1. I like to think 6 plus 1 is 7. And 7 plus 7 is 14. Put that 1 up there. Drop my decimal down. Then I have 1 plus 2. That's 3. 3 plus 3 is 6. I get 6 and 43 hundredths. Take a look at our answer choices. Bloop, there it is, letter D, is 6 and 43 hundredths. Moving on to number 4, it says, which decimal makes sense in this equation to make it true? So let's take a look at this. Kind of rewritten it here. I could spend a little bit of time maybe thinking it through and trying to figure out what's going to go in here. Or, since I know I'm taking this number, adding it with this number, and it's going to equal this, I could find this by just turning this whole thing around into a subtraction problem. I'm going to take 12 and 1/10, and I'm going to take away 4 and 95 hundredths to leave me with my answer. So I'm going to subtract. Now notice, it's super duper important to line up your decimals. When you do that, now your digits are kind of all wonky, right? We don't like wonky things. So I can always make this an equivalent fraction by adding a 0 at the end. Now I feel like I'm at peace with myself. I can go ahead and subtract correctly. So 0 minus 5, oops, can't do it, gotta borrow. The 1 becomes a 0, the 0 becomes a 10. 10 minus 5 is 5. 0 minus 9, oh, can't do that either. Got to borrow. The 2 becomes a 1, that 0 becomes a 10. 10 minus 9 is 1, drop my decimal down. I'm feeling good about my life. 1 minus 4, no, now I gotta borrow. The 1 becomes a 0, the 1 becomes an 11. 11 minus 4, okay, back on track with 7. And 0 minus 0, 0 minus 0 is nothing. So 7 and 15 hundredths. Let's just verify on number 4, and there it is, 7 and 15 hundredths, answer choice A. Let's move on now and take a look at number 5. Now number 5 says, Lawrence spent $1.89 on a bottle of paint and 45 cents on a brush. What was the total amount he spent? And it says, use the model to help you. Now, some of you might love the model because look, here's one hole in the green. And then also in green, if I count all that up, it's 89 green blocks. And then we have 45 cents over here on the brush. So there's one line with 4, one line with 4, one line with 10, 20, 30, 40. That's 40 blocks there. Plus that one there, it's 41. 42, 43, 44, 45. So the model is there to kind of help you out. We could literally just count up all of those, or if we like this method, we could just take $1.89 plus 45 cents and add them together. 9 plus 5 is 14. 8 plus 1 is 9. Plus 4 is 13. Drop my decimal down. 1 plus 1 is 2. So I know that my answer here is going to be $2.34. Now, the tricky part here is letter B. It says, explain how the model would help you. Now, if you didn't use the model, we want to know how the model could help us. And it could help us because the green represents the bottle of paint. The red represents the brush. We're just adding those numbers together based on the blocks. So for my answer for letter B, I could say the model helps me because I'm adding together the different values of the paint and the brush to find my answer. Moving on to number 6. Now, number 6 looks like maybe it could be difficult. I hope this is coming through clearly. On my screen, it looks very, very blurry, but you can look at it in your own paper, and maybe that's going to make sense. It says match each expression on the left with the equivalent decimal. Essentially, what we can do is just solve our problems here on the left and then match up our answers, right? So it's kind of presented in an odd way, but I'm going to go ahead and pull up my questions here. These are the questions that we see on the left. So I'm adding and subtracting with decimals. And I've pre-arranged these so my decimals are lined up. I've got the right operation signs, addition and subtraction. So let's go to work. I've got 5 plus 5, that's 10. 1 plus 6, that's 7. Drop my decimal down. 3 plus 1, that's 4. Okay, so for number 1 here, I'm going to look for 4 and 70 hundredths. But look, I don't see it anywhere. Remember, an equivalent decimal with 4 and 70 hundredths is 4 and 7/10. So there it is. Let me move on. Now I've got a subtraction problem. 8 and 5/10 minus 4 and 8/10. I can't take 5 minus 8, so I'll borrow. That becomes a 7. The 5 becomes 15. 15 minus 8 is 7. Drop my decimal down. 7 minus 4 is 3. I get 3 and 7/10. And wouldn't you know it, 3 and 7/10 is one of my options that I can select. Let me move on. I've got 4 and 25 hundredths plus 1 and 55 hundredths. 5 plus 5 is 10. 5 plus 2 is 7, plus 1 is 8. Drop my decimal down. 4 plus 1 is 5. I get 5 and 8 tenths, or 5 and 80 hundredths. So we can convert that over. And then I'm subtracting 11 and 4 tenths minus 6 and 6 tenths. 4 minus 6, I can't do it. I'll borrow. That becomes 0. The 4 becomes 14. 14 minus 6 is 8. Drop my decimal down. I'll borrow here again. 10 minus 6 is 4. That's 4 and 8 tenths. And again, that's one of my options as well. So that's number 6. Again, a lot of math going on there, but nothing that we're not capable of doing. Let me move on and take a look at number 7. This is tricky now. Okay, so number 7, we've got Ed, who's running and training for a race. He ran so far on one day, and then the next day, and the third day, we want to find the combined distance. So here's all of his days that he ran, right? I'm just going to add these together. Now, I might add them in a particular way, and maybe there's some numbers that make sense for you. For example, I see a 6 and a 4. So I'm going to go ahead and take 12 and 56 hundredths and add 13 and 4 hundredths to that, because I feel like those two numbers are destined to be. 6 and 4 is 10. 5 and 1 is 6. Drop my decimal down. 2 and 3 is 5. 1 and 1 is 2. Now I'm going to take my 25 and 60 hundredths, and I can't forget about that other day, that second day. I'm going to add that on. So I have 25 and 60 hundredths. I'm going to add on the 12 and 98 hundredths. 8 plus 0 is 8. 9 plus 6 is 15. 1 plus 5 is 6, plus 2 is 8. And 2 plus 1 is 3. So the total distance here that Ed ran is 38 and 58 hundredths miles, right? So the combined distance, there it is. How much further did he run the second day than the first day? Well, that's a totally different problem, right? So now I need to take that first day and the second day and subtract them. I'm going to start with my bigger number, which is the second day, and then take away 12 and 56 hundredths. Okay, 8 minus 6 leaves me with 2. 9 minus 5 is 4. Drop my decimal down. And 2 minus 2 is 0. 1 minus 1 is 0. I get 42 hundredths of a mile. And that is number 7. Moving on, number 8. Another word problem that might be kind of tricky because of all the words, but don't let the words fool you. It says the Thomas Jefferson Memorial is on 18 and 36 hundredths acres of land. The Franklin Delano Roosevelt Memorial is on 7 and 5/10 acres of land. The Vietnam Veterans Memorial is on 8 and 9/10 acres of land. And the World War I Memorial is on 9.6 acres of land. Which two memorials have the greatest difference in area? All right, so I'm going to go ahead and take a look at this, and here's all my numbers, right? Taking the words out, looking at just the numbers, I want to find the numbers that are furthest apart. Which two have the greatest difference between them? I don't even know if I need to do math here, right? I can just look at the numbers and think about them. But if we're putting these onto a number line, and this is going to be a very crude number line here, but I know that FDR is going to be way down here at 7 and 5/10. Next, I'm going to have the Vietnam Veterans Memorial at 8 and 9/10. The World War I Memorial is at 9 and 6/10, and then way far ahead is that Thomas Jefferson Memorial, and that one is at 18 and 36. So really the ones that are going to have the furthest distance between them is going to be the FDR and the Thomas Jefferson Memorial. Now what's kind of neat about this is that we can explain that using the logic that we had. We also could explain it by doing the math, by actually subtracting and using some hard number evidence. So let me just show you how we can do that. So we have 18 and 36 hundredths, that's Thomas Jefferson. I'm going to take away the FDR, which is 7 and 5/10. Notice I lined up my decimals, and I want to make sure I add my 0 to make sure my place values are lined up. 6 minus 0 is 6. 3 minus 5, I'm going to have to borrow. That becomes 13 minus 5, which is 8. 7 minus 7 is 0. And 1 minus nothing is 1. So the difference is really 10 and 86 hundredths acres. It's a pretty big difference between those, and so we can explain that here on number 8. Moving on, number 9. Number 9, it says Amber bought a hardcover book for $23.70 and a paperback for $6.91. How much did she spend in all? Okay, so let me tackle that first question first. So here we go. Here's Amber's books. We want to find the total. We're going to add these together. Notice my decimals are lined up. 0 plus 1 is 1. 7 plus 9 is 16. Drop my decimal down. 3 plus 6 is 9, plus 1 is 10. And 1 plus 2 is 3. That means that Amber spent $30.61 in all. Let me go back to that second part of the question. If she paid with two $20 bills, how much change did she get? Well, we got to think about this. If she has two $20 bills, how much is that? 20 times 2, that means she spent $40, or she paid with $40. So to figure out the change, I'm going to take that $40, and I'll add on my zeros there to make sure my place values line up, and I'll subtract away the $30.61. So now we just have a subtraction problem. So I'm going to have to borrow and borrow and borrow. The 4 becomes a 3. That 0 becomes a 10, what really is a 9. And then this 0 becomes a 10, but really a 9. And then this 0 can finally become a 10. 10 minus 1 is 9. 9 minus 6 is 3. Add my decimal point. 9 minus 0 is 9, and 3 minus 3 is 0. So that means her change that she'll receive is $9.39. So I can explain that here for number 9. Moving on, the last question. Maybe the hardest one because there's a lot going on with it. But we want to look at this one. And this is our patio. Now I've tried to draw the patio out just like they did here, only so that it's easier for me as I'm working on the page. It's like a duplicate. I don't really need to draw that, but maybe you do, and maybe that'll help you. So first up, it says in letter A that we're going to round these lengths to the nearest whole number. So again, going back to rounding, I'm going to underline the whole number. That's going to be the ones place. I'm going to draw my arrows to help me remember that it's the number on the right that determines that value. So the 5 is going to stay a 5 because that value is 4. That's a 5. The 12 is going to move up. It's going to round up to a 13 because the 7 is 5 or more. So we're going to raise the score. So now we have lengths here of 5 and 13. So I'm going to redraw this out. Okay, this is 13, 13, 5, and 5. If I'm finding the perimeter, I'm just adding these numbers together. Okay, I might be able to do this mentally, right? 13 plus 13 is 26. 5 and 5 is 10. 26 plus 10 is 36. So my perimeter is 36 meters. I guess I should put my label on there. 36 meters when I round to the nearest whole number. In part B, same measurements, but now we're rounding to the nearest tenths place. So I'm going to underline my tenths place, draw my arrows. I'll round. In this case, the 5 tells the 4 to go up. So that's now 5 and 5 tenths. The 4 tells the 7 to stay. So now that's 12 and 7 tenths. Again, I'm going to draw this out. I'm not the best drawer, so please don't judge. We have 12 and 7 tenths, 12 and 7 tenths, 5 and 5 tenths, 5 and 5 tenths. In order to find the total perimeter, I'm going to add these together. Again, mental math might help out, or we could kind of do it the regular way. So I'll do it the regular way on this one, just to kind of show us how this can be done. I have 12 and 7 tenths plus 12 and 7 tenths. 7 plus 7 is 14. 2 plus 2 is 4 plus 1 is 5. And 1 plus 1 is 2. So 25 and 4 tenths just for those two sides. Next, I have 5 and 5 tenths plus 5 and 5 tenths. Add them together. 5 plus 5 is 10. Drop my decimal. 5 plus 5 is still 10, plus the 1 is 11. So now I'm taking 25 and 4 tenths plus 11 to figure out the total perimeter. So I can do this. I didn't really leave myself a whole lot of room, so let me do this over here. 25 and 4 tenths plus 11, and I'll say 11 and 0 tenths to make it easier and everything's lined up. 4 plus 0 is 4. 5 plus 1 is 6. 2 plus 1 is 3. And my decimal needs to drop right down. So the perimeter here is 36 and 4 tenths meters. The last thing is we want to find the exact numbers, right? That's part C. So I'm going to add them all together. I have 12 and 74 hundredths plus 12 and 74 hundredths. Just adding the top and the bottom here. So 4 plus 4 is 8. 7 plus 7 is 14. Drop my decimal down. 2 plus 2 is 4, plus 1 is 5, and 1 plus 1 is 2. Okay, that's one side. Next, I have the 5 and 45 hundredths. So that's like the left and the right side. Add these together. 5 plus 5 is 10. 4 plus 4 is 8. Plus that 1 is 9. Drop my decimal down. 5 plus 5 is 10. Now I need to add those two together. So I have 25 and 48 hundredths plus 10 and 90 hundredths. Add them together. 8 plus 0 is 8. 4 plus 9 is 13. Drop my decimal down. 5 plus 1 is 6 plus 0 is still 6. And 2 plus 1 is 3. So my total here is 36 and 38 hundredths meters. So you can see how my answer kind of changed. I had 36 meters, I had 36 and 4/10 meters, and then 36 and 38 hundredths meters. And that, my friends, is our review for Chapter 2.